Hi everyone, my name is Estefanía Peralta and I'm a PhD student in the Laboratory of Bioactive Compounds Research and Development from La Plata, Argentina. Today I am presenting the poster entitled Virtual Screening Applied to Search for New Antiepileptic Drugs Active in the PTC Kindling Model. PTC kindling in mice is a model of chronic epilepsy. It has been explored for studying epileptogenesis and refractory epilepsy. In this work, computational models were developed by machine learning to be used in virtual screening in order to identify new drugs with promising antiepileptic activity in the phenotypic model. With this in mind, were performed a literature search for compounds previously tested against this model in mice. The compounds were standardized and the duplicates were removed. So finally, we had 176 compounds that were classified as active and inactive, according to different performance and in the PTC kindling murine model. Then we performed a clustering technique to representatively sample the dataset to obtain training and test sets. The IRAPCA clustering is based on an interactive combination of feature banding, dimensionality reduction through principal component analysis, and the K-means algorithm. In this manner, we obtain a balanced training set and two validation sets. Validation set 1 was used to evaluate the performance of the individual models in a retrospective virtual screen, and to obtain a model ensemble, it was also used to decide which individual models would be combined and how. The second validation set was used to validate the chosen model ensemble. We generated 9 two-sound QSAR models. We proceeded to perform an ensemble of linear models using the minimum operator. The ensembles of the 4 models were calculated, and a graph with the number of models versus AC rock and versus B rock was plotted. One concern when performing virtual screening campaigns is the prediction of the probability of conforming an in silico hit when submitted to experimental confirmation. This probability is called positive predictive value, and its variation with the cutoff value can be viewed graphically in a 3D plot displaying the interplay between the PPV, the selectivity specificity ratio, and the yield of actives of the screening chemical library. We show a strict cutoff score. The table displays the enrichment metric calculated for validation set 2 on screening with the model ensemble, showing good early enrichment capacity. Finally, the ensemble of 4 models was applied to a prospective virtual screen of drug bank. From the total compounds, 523 passed the strict cutoff score, selected previously by the PPV surface, and from those, only 371 belonged to the applicability domain. Finally, we selected 47 compounds proof. According to the pharmacokinetic characteristics and accessibility, compounds from drug repurposing database would be purchased and evaluated in the PTC kindling murine model in the near future.